We are a team at New Mexico Tech competing in the NASA RMC Challenge. Over the past 2 semesters, we have worked to complete our second generation of robot named David with 2 eyes. This is an anecdote to our previous robot named David with a single eye, as it is the second generation of our robot. We will quickly go through the key points, narrating our proof of life video, and ending there.
4, 3, 2, 1, go.
Okay, so our robot is starting. We are doing a countdown to initiate it. We have started moving forward. As you see, we have a crater on the right and some obstacles on the left, so we need to turn the robot to the right. We do this by adjusting the left tread, keeping the right stationary, and avoiding the obstacles. We have to adjust right. Then, once we have passed the obstacles, we want to left again to avoid that second pile of rocks. To do this, we are using our communication system as it would work in a normal competition scenario, and sending data over a communication bus to all of the components of the system. Reading, we get turning the bucket, we will soon drive the pitch motors down and the stepper motors forward. As you can see, our rail is moving forward so that our excavation will start digging into the sand. There go our pitch motors. We are now digging into the sand. Our bucket composes of 2 openings so that as the bucket is rotating to the sand, it is collecting and housing the sand. We also include holes to try to filter out some of the small particulate matter that is less interesting to us. Successfully dig to the required depth will complete several excavation motions and each process. Currently, we are extending the stepper motors so that we can get the sand once we start dumping away from our hole that we created. It could be challenging from a control system perspective to keep track of the amount of material that is located within the excavation system at any given time. So in the future, we'd like to have sensors in order to detect such a the excavation event. At the moment, we are making small corrections to the relative orientation of our pitch motions in order to make sure that the robot maintains stability. Now we are retracting in order to start a second configuration. Further adjustments of pitch and depth motors can help to contribute. We have now begun our third excavation. This will be the dirt the gravel that we will collect and have to attempt to reverse back towards the location of the hopper in order to dump the material. At this point, we realize that our driver shaft, or the driver gear, attached to our powerful motor had been sheared on the inside. This had happened multiple times during our test runs, and this final time was one that finalized the breakage on the inside of the key. Because of this, we needed to do a quick repair. Although we would love to have had a single run, we have attempted multiple times with different parts, but at the end of the day, we were stuck with the single gear motor or gear shaft that we had, and so we had to make a quick repair and hopefully complete the rest of the run. Right now, we are just quickly attaching the new or the previous gear back on, but we are also adding zip ties to the motor to reduce the vibrations, and we had not expected the vibrations and the leverage created by the torquing of the motor to be so severe.
We would also like to add that this footage has been sped up for brevity.
Now restarted at the same place that we had stopped. At this point, we are trying to turn the robot around in a more clear and open area.
We're interested in completing a 360-degree rotation in order to align the dumping element, which is also our dumping element, with the dump heap.
However, as you can see, our part that we had used had begun to shear again, and as a result, the permanent damage to the inside of that gear shaft caused it to start moving outwards every time that we torque the motor. The natural tension within the band is just pulling the shaft forwards and out through the shaft of the gear or of the motor, and as a result, it had come undone again.
We attempted to compensate for some of these issues by taking smaller increments in our steps and using gentler command inputs. However, it was not enough to resolve the issues. Nonetheless, thanks to the ingenuity and speed of our mechanical team, we were able to repair the issue and attempt to finish the run.
We have restarted with the drive motor once attached once again.
We are retracting the excavation system in order to reduce the amount of force we apply on the locomotion system as we rotate the robot. By completing small forward and backwards motions, we attempted to reduce the stress on the locomotion system. For the final time, our gear had come undone again. We tried to do one more quick repair just to see if we could get the robot to go all the way to the hopper. During this time, we were careful to not adjust any other aspects of the system beyond this locomotion issue. The robot also received continuous power draw and communication throughout all of the repairs. This time we had repaired the step, however it just fell off immediately. But we are moving the robot to the hopper. This is in order to demonstrate the dumping action.
Hold it. Hold it.
You will see the timer start and stop. We believe that keep the timer going throughout the run, even though it is not a continuous run, may still be beneficial towards during this maneuver, we pitch the forks up, pushing the bucket containing the gravel and sand into the. We then move the stepper motors forward so that we can gain clearance over the edge of the hopper, and then reverse the bucket into the counterclockwise or the opposite rotation direction that the bucket had been spinning in order to release all of the dirt and gravel. I'd like to note that we have on our system both the emergency stop button and the power meter displayed on the back.
I'm just gonna hold you.
Eat it now.
Hold it.
In quick rotations, we have dumped all of the material within the bucket. We are now retracting the bucket back into the robot, and as soon as the bucket has been retracted, we will end.
Hey Nathan? Give me Sapa.
Yeah.
Can you make it go in more?
At this point, the robot has finished its life trial. We will now sift through the gravel and remove as much as we can of the sand and only contain just the larger particulates, and then weigh them. At this point, we are sifting all of the sand through the gravel. Once this is complete, we will collect all of the gravel and store it in a bucket. We will then weigh the bucket, remove the gravel, put the bucket back on 0. We will then announce our final weight.
Use that to do collector.
Yeah.
Yeah, hold on. Is the scale 0 to that?
We need to show that it's 0 so what we can do is we
Yeah.
can just weigh it and then
Okay.
take this out after.
Okay.
So this is with this.
With the container, yeah. So.
Yeah?
Yeah.
What I should do?
So read it and then we'll jump and we'll zero this.
And then we'll.
All right. 0.8 kilograms.
I would say your full name too.
So I'm Mustafa Sanalian. I'm the advisor of the team. So we are weighing the weight of the rocks, right?
Plus the container.
Plus the container. So the weight of the rocks plus container is 0.8 kilograms. So now we are going to measure the weight of the container and we just subtract them. So the weight of the container is 0.6 kilograms. So the weight of our rocks is 0.2 kilograms or 200 grams.
Okay, we're about.